people genuinely feel things are getting worse. And I think that's because our information about what's wrong with the world, including violence and poverty and environmental degradation, is getting exponentially better. I have all kinds of graphs. Poverty has fallen over 90% in the last 20 years in Asia and comparably in other parts of the world. Solar energy is doubling every 2 years. It's only 5 or 6 doublings from meeting 100% of our energy needs, at which point it'll be using 1 part in 10,000 of the sunlight that falls on the earth. Literacy went from 10% to 90% in the world over the last century. Every aspect of human well-being is getting dramatically better. And we're going to see dramatic advances in longevity very soon, now that biotechnology, which is really reprogramming the software of life, is getting traction. We have a trickle of instances today that'll become a flood over the next decade. This is the most peaceful time in human history. People think I'm nuts when I say that. Didn't you pay attention to the incident yesterday and the week before? But that's because, a century ago, the village nearby could have been wiped out and you wouldn't hear about it for months. We have more information about what's wrong with the world. And we have an evolutionary preference for bad news because it was actually good for survival. The little rustling in the leaves, it might be a predator. It was very important that you pay attention to that. The fact that your crops were 1% better than last year was not so important for survival. So we tend to pay attention to bad news. We find it more interesting anyway. That's what's served up to us. People's algorithm for whether the world's getting better or worse is how often do they hear good news versus bad news, and that's really not a very good algorithm. I've actually spoken more about the risks of these new information technologies, artificial intelligence, biotechnology, nanotechnology, than most others. I started writing about it actually in the age of intelligent machines in the 80s. The age of spiritual machines talked a lot about the downsides of what was called GNR, genetics, nanotechnology, robotics, and started kind of a firestorm of this issue that these new technologies, which seem to be bringing a lot of good things, did have risks attendant to them. Subtle risks like privacy and bias inherent in AI, and then existential risks, which we've certainly seen portrayed in dystopian futurist movies. I do take comfort from the fact that we don't see the scenario that's portrayed in many of these movies, where it's the AI versus a brave band of humans for control of the world. There isn't 1 or 2 AIs in the world. There's several billion of them at last count, and they're very closely integrated with us. When I was in college, I had to take my bicycle across campus to get to the one computer we all shared. I went to MIT because it actually had a computer, and also to study with my mentor, Marvin Minsky. Now they're in our pockets, they hang from our belts, they're going to go inside our bodies. That's already started. And so AI is really a brain extender. That's why we use technology in general, is to go beyond our limitations. We couldn't reach fruit at that higher branch 1,000 years ago, so we created tools that extended our reach. Who here could build this building? So we have tools that leverage our muscles. A teenager in Africa can now access all of human knowledge with a few keystrokes with their smartphone. So they are brain and body extenders. They're going to literally make us smarter. We can talk about my scenario for how I think that will happen. And I think that tends to keep it safe. And we have a scenario or a paradigm for keeping these technologies safe. 40 years ago, some visionaries saw both the promise and the peril of biotechnology. Neither was actually feasible at that point, but they held a conference at the Asilomar Conference Center in California, which became known as the Asilomar Biotech Conference, and came up with the Asilomar guidelines for strategies to keep biotech safe and ethical standards for responsible practitioners. And there's been successive conferences. This has been updated every few years, and it's worked very well. We're now getting profound benefit. It's just a trickle today. It'll be a flood over the next decade from biotechnology. The number of people who've been harmed by either intentional or accidental abuse of biotechnology so far is approximately zero. That doesn't mean we can cross it off our concern list. Okay, we took care of that one. But it is a good paradigm for how to keep these ultimate technologies safe. We just had our first Silmar conference last year on AI ethics. I think it is the most profound issue facing humanity. How can we reap the profound promise of these exponential technologies while managing the peril? Time AI or biotech or any of these technologies actually affect something, there's a tremendous amount of oversight. So let's say in medicine and biology, we've got the FDA and all kinds of regulations. Anytime any of these technologies affects anything we do, there's a tremendous amount of regulation. So it's not like we live in an unregulated society. And these things, influence us in terms of products and services. We have a myriad of regulations, and there's debate as to how extensive those should be. So it's not unregulated. It's very hard to regulate just a basic technology until it actually affects something. There are issues now, for example, AI is learning from humans, and apparently some humans have bias and opinions that we don't want our AIs to share. So there's a lot of effort to try to recognize the bias in AI and try to address that. We try to recognize the bias in humans and try to counteract that. So anytime AI actually impacts the world, there's a lot of observation of it. You mentioned Smart Reply, which comes from my group at Google. We've gone to efforts to try to actually understand the emails correctly and not provide biased responses, but the software does learn from humans, so we have to constantly look after it, make sure that it reflects the kind of values we want. But at the same time, it's not a clear-cut issue, because we don't want to be censoring the software either and providing one set of values over another. We try to keep it neutral, but so that's one example of trying to monitor the behavior of AI. In terms of it being dangerous, I mean, again, if it's, for example, something that goes inside the body, there's a tremendous amount of regulation. There is concern of AI being used in military systems. I think really that strategy, I think that what makes the most sense is to try to practice the values that we espouse and hold dear in our social and political systems to begin with. And that may not sound like a foolproof strategy, and it's not. But AI is really an amplification already of human judgments, human policies, human ideas, and even before we had AI, human behavior has not been perfect. But I would say that we're moving towards a more peaceful world, a more democratic world, with the increase of communications. We had the first stirrings of democracy with Gutenberg's books. And the number of democracies in the world a century ago, you could count on the fingers of one hand. The number of democracies 2 centuries ago, you could count on the fingers of one finger. The world's not a perfect democracy today, but there are dozens of well-functioning democracies. It has become a consensus that that is how we want to govern the world. And this is the most peaceful time, because we've become very sensitive to we have a natural empathy for small groups of people. So there's some outrage 10,000 miles away, and our hearts go out to that, and it's painful, but it actually generates action and reaction. There were 50 million people killed in World War II, and people might read about it in a small newspaper article days later. A century ago, you wouldn't even hear about these battles at all. By every measure, your chance of being killed in either state-sponsored violence or interpersonal violence is dozens, if not hundreds of times less than it was centuries ago, I think because of the prevalence of communication technology.
So I want to come back to something you said a minute or two ago about human bias and the bias that inevitably infuses AI as it learns from its creators. And a situation that is improving, but still as it stands right now, largely there's a lack of diversity amongst the engineers and programs who are creating this technology. Do you feel that there are concrete steps being taken on behalf of the engineers and programmers to make sure that their own subconscious biases and their own empathetic tendencies aren't being infused or learned by the AI?
It's a good question, and I think a more significant issue is AI is learning from humans.
Right.
It'll read millions of documents, and that's how it learns about the world. There are significant efforts at all of these companies, Google, Microsoft, Apple, to debias software, recognize biases that we don't want. So for example, software just reading about the world may come to the conclusion that surgeons are male, because that's what it reads. And that's not an association we want, because surgeons are females and can be. And so we try to correct that, but it's a complicated issue. Because then you're starting to provide your own values, and what should those be, and the whole idea of services provided by companies like Apple and Google is not to provide the values and ideas of the company. Nonetheless, there are efforts to try to debias software. A more significant issue than unconscious bias by the engineers is really the bias that exists in the human documents that these programs are learning from. So that's an ongoing issue. It's a major effort on the part of all these companies. We've looked at smart reply. It's actually complicated because we can't actually read people's emails, because that's another issue, which is privacy. So we have to actually wait for people to potentially complain. And we're actually getting very positive responses. We're not getting complaints that the software is showing bias, and that's because of efforts we put in to try to avoid that. But it's not a straightforward issue, because it's the same thing with humans. I mean, human children learn from other humans and will adopt, consciously or otherwise, the biases in their midst. So it's a role of education, is to provide the values that we espouse as a society.
What you're saying about AI learning biases from documents is really interesting to me. Do you think there's some sort of conscious effort, or will there be some sort of effort on behalf of the engineers to, I don't know, create an algorithm or something such that the biases, let me rephrase that. Would there be a bias filtering process?
Well, that's exactly what is being worked on, to try to avoid really egregious examples of bias that we generally recognize as being out of the mainstream. But then you're trying to provide ideas and balances of views that are beyond what's reflected in human documents that the systems are learning from. And so then you have to decide what are the ideas that you want to espouse, what are ideas that you don't want the systems to learn, and that's complicated and difficult. The idea is really not to filter out. I mean, Google is really trying to provide information. When you search for something, you may find documents in your search that reflect ideas you don't agree with, but that's intentional. We don't want to be filtering out human ideas. We want really to be a neutral exploration of them. So it's an area of ongoing effort to try to avoid obvious problems, but where you draw the line is complicated.
You started this session by saying you were an optimist, and do you feel that you kind of get a bad rap for being an optimist?
Well, the world does have a pessimistic view. There was a poll taken of 24,000 people in 26 countries, and they were asked a number of questions. Poverty is a typical one, and people were very pessimistic. They were asked, has poverty gotten better or worse in the world over the last 20 years? 90% said incorrectly that it's gotten worse. Only 1% identified correctly that it's fallen by 50% over the last 20 years. So people really feel that on all these measures, literacy, poverty, health, things are getting worse when they're actually getting dramatically better every year, and exponentially so. But we don't recognize that. I had an onstage dialogue with Christine Lagarde at her annual meeting of the International Monetary Fund, and she said, well, where's the productivity enhancement that we're supposed to see from digital technology? I said, well, we don't measure it because we factor it out. We put it in the numerator and the denominator. So when this teenager in Africa spends $75 for her smartphone, it counts as $75 of economic activity, despite the fact that it's literally $1 trillion of computation and communication circa 1965, $1 billion circa 1980. It has millions of dollars of free information apps, just one of which, one of thousands, is an encyclopedia, much better than the one I spent thousands of dollars for as a teenager and saved up from my paper route. And it counts for nothing because it's free. So we don't count all of these fantastic productivity gains, because the dollar of information technology is still a dollar. She said, okay, that's true of this fantastic world of digital technology, it's remarkable, but you can't wear information technology, you can't eat it, you can't live in it. And my next point was all of that's going to change as well. We're going to print out clothing at pennies per pound. Not yet. We need really submicron resolutions and faster speed and lower costs and 3D printing, but in the 2020s, there'll be lots of cool designs you can download for free, print out for pennies per pound. For clothing, people still spend money for cool proprietary designs, so the fashion industry won't go away, just as the music industry hasn't gone away with online music. You'll print out modules, snap together Lego-style houses and buildings. That's been demonstrated in Asia. We'll have vertical agriculture, hydroponic plants for fruits and vegetables, in vitro cloning of muscle tissue for meat, controlled by AI, very inexpensive. The 50% deflation rate that's inherent in information technology will then be attendant to these kinds of resources we don't associate with being information technology. And finally she said, okay, but the one resource that you can't really produce in this exponential way is land. We're already very crowded together. And I said, it's really not true. We're only crowded together because we decided to crowd ourselves together. Cities was an early technology so we could aggregate, congregate, and work and play together. Try taking a train trip anywhere in the world and you'll see that 95% of the land is unused. And we can spread out when we have virtual communication that allows us really to work and play anywhere and still be together.
Okay, I'm going to pivot for a second, because you've got some new work that illustrates principles and possibilities for a brighter future, and a roadmap for your optimism, if you could talk about that for a second.
Yeah, well, about 10 years ago I had these fantasies of a young girl who was very precocious and very intelligent. It was really an exercise in the power of intelligence, and that's been my theme, but I've talked about it in an abstract sort of nonfiction way. So I was imagining, what if there was a very precocious young person, say a young girl, who was remarkably intelligent? What impact would that have on the world? And so I wrote a novel called Danielle Chronicles of Superheroine. This is a picture of her. I don't know if you can see that from here. And the story is told by her sister Claire. Claire is a survivor of the Haitian earthquake. She's adopted by an American family when she's 6. 2 years later, her sister Danielle is born, and she tells the story of Danielle from 0 to 22. And Danielle solves a lot of problems. She cures cancer when she's 12. She finds that she actually can't distribute this cure because of the Food and Drug Administration, so she does a very clever end run around that, again using her intelligence. She brings peace to the Middle East. She becomes president of the United States at 19. They pass a special one-person amendment for her. And in the preface, I state this is really a thought experiment. What if one person was extraordinarily intelligent and also courageous and creative and compassionate? What impact would that have? And then I say, imagine if we were all Danielles, and that will happen by 2045. So this is a fictional way of really expressing my sentiments about the power of intelligence and personal courage. If you pick up this card, if you didn't get one on the way in, you can pick it up on the way out and get a free book inscribed by the author, which is me, when the book comes out this summer. Your shipping information won't be shared with anyone, but that's a free copy of the book.
Says the guy from Google. We tease because we love.
It also includes 2 nonfiction companion books, which is kind of a literary first. One is How You Can Be a Danielle, which is practical advice, how you personally can use your intelligence and courage to positively impact the world, including children. And then there's another companion book called A Chronicle of Ideas, which is Danielle's and my unique spin on the concepts in the book.
And we have a trailer for that, if we could cue that up real quick.
That'd be great.
People always ask me, what's it like? What's it like to be the sister of a superheroine? I tell them it's fun. I remember when our stage was small and we'd sing our stuffed animals to sleep. I tell them it's beautiful. I remember the night we traveled across Zambia by donkey. We'd come to help with the water crisis. I tell them it's exhilarating. I remember the moment Danielle resolved the Libyan civil war. I tell them it's inspiring. I remember Danielle at the congressional podium, uniting left and right, her greatest stage yet. And I tell them sometimes it's hard. Danielle's brilliance can't always save her from sadness. It's a good thing I'm here.
Claire, I need you.
What's it like to be Danielle's sister? It's the best material a writer could ask for.
We've spoken, and you've spoken before, about the hierarchy of intelligence. Danielle clearly has augmented intelligence. How far up the hierarchy?
Okay, so this is a 200 million year story. How much time do we have?
We're fine.
So 200 million years ago, mammals evolved with a brain structure called the neocortex, which means new rind, which is an outer layer of the brain that could actually understand the hierarchical nature of the world and could invent new behaviors. So these early mammals were rodents, and they could invent a new behavior. So they're escaping a predator, its path is blocked, it'll invent a new behavior to cope with that. Probably wouldn't work, but if it did work, it would remember that. That could actually spread virally through the community. Another mouse watching this might go, that was really clever going around that rock. I'm going to remember to do that. And they would invent a new behavior. Animals without a neocortex, which is to say non-mammalian animals, couldn't do that. Didn't help very much because all the non-mammalian animals were very well evolved for their ecological niches. So the mammals stayed out of the way. And not much happened for 135 million years. 65 million years ago, something did happen. There was a sudden violent change to the world. If you dig down to an area of rock reflecting 65 million years ago, the geologists will explain that this shows a sudden, violent, catastrophic change to the environment. And we see it all around the globe. And we call it today the Cretaceous extinction event because that's when the dinosaurs went extinct. 75% of all the animal and plant species went extinct because it couldn't cope with this change. That's when mammals overtook their ecological niche. And to anthropomorphize, biological evolution said to itself, this neocortex is pretty good stuff, and it began to grow it. And now mammals got bigger, their brains got bigger at an even faster pace, taking up a larger fraction of their body, and the neocortex got bigger even faster than that, developing these curvatures that we associate with a primate brain. And so now primates really became ascendant. 2 million years ago, biological evolution decided to expand the neocortex even further and develop these large foreheads to house the frontal cortex. Up until recently, it was thought that frontal cortex must be qualitatively different because it does such different things. My thesis has always been it was just an additional quantity of neocortex. Now, the neocortex is organized as modules. Each module can recognize a pattern, and they're organized in hierarchies, and we create that hierarchy with our own thinking. It's a thesis I actually had 50 years ago. It's how I got to meet President Johnson, and I've been thinking about this for 50 years. We're using an architecture along these lines for Smart Reply and other software at Google that can actually understand the meaning of natural language. So we got an additional amount of neocortex 2 million years ago with these large foreheads. Remember what we did with it? Well, we were already doing a very good job of being primates, so we put it at the top of the neocortical hierarchy. And as you go up the hierarchy, things get more interesting. At the very bottom of the hierarchy, I can tell that that's a straight line. At the top of the hierarchy, I can tell that that's funny or that's ironic. So that additional neocortex, at additional levels of hierarchy, was the enabling factor for us to invent language and art and music. Every human culture we've ever discovered has music. No primate culture has music. There's debate about that, but I believe it's the case. So we're going to do it again. We're going to create synthetic neocortex in the cloud. We have rough models of the neocortex already. It's not perfect, but that's what we're trying to do today. I think by the 2030s, we'll have very realistic models of the neocortex, and we'll have medical nanorobots that go inside our bodies, keep us healthy by extending the immune system, providing virtual and augmented reality from within the nervous system, but most significantly, attaching the top levels of our neocortical hierarchy to synthetic neocortex in the cloud. Just the way that this connects to the cloud, and these are brain extenders. They're not directly connected in the brain, and they're not really connecting to extend our neocortex today, but that's what it'll do in the 2030s directly from our neocortex. The only difference from what we did 2 million years ago is that was a one-shot deal. If our foreheads kept expanding, birth would have become impossible. This expansion wirelessly into the cloud will not be a one-shot deal because the cloud is not limited by a fixed enclosure. It's growing exponentially as we speak. So it will become a hybrid of biological and non-biological intelligence. The non-biological part will grow exponentially. And again, just like it did 2 million years ago, we'll put it at the top of the neocortical hierarchy. So we'll invent new ways of relating, communicating with each other, new art forms that we can't even imagine today. Try explaining music to a primate or language to a primate that just doesn't have enough neocortical capacity to comprehend those concepts. We'll again create fantastic new ways to relate to each other. But that, as I said earlier, is what we do with technology. It extends our reach and we go beyond our limitations. We're the only species that does that.
So
did that answer your question?
it does, but it also essentially, you're essentially projecting that after a certain point, or at a certain point, we'll be able to augment creativity. And
Right.
what does that mean for unenhanced creativity, and how do we measure one against the other?
Well, I mean, who's unenhanced today? Maybe the Amish choose not to use cell phones. I'm not sure. They do use some technology. 98% of people use some form of digital enhancement. No, who here could do their work or get an education without the brain enhancers we already have? And people say, oh, well, only the wealthy be able to afford these forms of enhancement. I say, yeah, like smartphones, of which there's 2.5 billion in the world today. There'll be 5 or 6 billion in a few years. In fact, you had to be wealthy to have a mobile phone 20 years ago, and they didn't work very well, and they only did one thing, which is make phone calls poorly. Today they do 1 million things, and they're in billions of hands. So that's because of this 50% deflation rate with digital technology. It's only affordable by the wealthy at a point in time where they don't actually work. By the time they work well, they're ubiquitous.
I guess let's not say enhanced then for a second. Let's talk about augmented creativity, creativity post-singularity.
Well, I mean, we're already augmented. My father was a brilliant musician. He couldn't hear his orchestral compositions. He'd have arguments with funders late at night to fund assembling an orchestra so he could hear his compositions. Then finally, when he got the money, I'd be up late with him running off scores on a mimeograph machine, which was hand-fed, and then he could finally hear his composition. But he couldn't change it, except maybe a few notes on the fly. I'd have to dismiss the musicians and start over again. Today, a kid in her dorm room can create a whole orchestra or a jazz band, with her MIDI keyboard and synthesizer software. So and software is creating walking bass lines and help calculate rhythmic progressions, and there are all kinds of writing tools. More sophisticated ones are coming. So it's already enhancing our creativity. We'll literally be able to comprehend more complex forms of communication, just as, say, music is a more sophisticated form of communication than what primates can do, when we actually can enhance our neocortex with its extension in the cloud.
Creativity, art, empathy, these are often the qualities to which humans assign meaningful interaction.
Right, and they exist at the top of the neocortical hierarchy.
What does meaningful interaction mean to an AI, to machine intelligence?
Well, AIs are not at human levels yet. They can do lots of things that we used to ascribe to human intelligence. In fact, one definition of AI is the field of computer science problems we haven't solved yet. As soon as we solve a problem, we say, oh, well, it's obvious that computers can play superhuman levels of chess, because that's just a combinatorial game. Of Go, the rules are pretty simple. It was only a year ago that people said, oh, well, computers will never play master games of Go. It's also interesting to note that once a computer does something at sort of average adult human levels, it very quickly soars past it. So it's a moving frontier. Just a few weeks ago, computers for the first time can take these reading comprehension tests where you read a paragraph and then you have to answer questions about it at slightly better than average adult performance. There's been some criticisms of the test, that the test doesn't really assess what's called multi-chain reasoning, where you have to take several different things in the paragraph plus some real-world knowledge and put that all together to answer the question. So we're creating more sophisticated tests. But clearly, computers are, the range of performance is getting broader and broader. Driving a car used to be considered a very complex thing, and it's not a simple task like just playing a board game. You've got to take all kinds of things into consideration, including trade-offs of what the risks are of different types of actions. And the Waymo cars have gone 3.5 million miles with no incidents, which is better than humans would do. So the range of activities is getting broader and broader. Still, actually, dealing with human language at human levels, say reading a novel and describing what it's about and writing a review of it and so on, these are still beyond what computers can do. That's the significance of my 2029 milestone. And I think once they achieve human levels, they will quickly go beyond it, like we saw in Go. It was only, I don't know, a year and a half ago that computers were sort of fair, average Go players. Then they quickly defeated Lee Sedol, one of the best, if not the best, Go player in the world. And then AlphaZero quickly soared past that, using no human training. So we see very rapid progress once a computer can do something at human levels. But again, it's not an alien invasion of intelligent machines from Mars. We create these tools to make ourselves smarter and extend our own reach, and that will be the ultimate application of AI.
At some point when these tools do reach our level of intelligence, do you foresee there being a point at which we should be assigning some sort of rights to these machines?
Well, it's an interesting question. I wrote kind of a tongue-in-cheek movie called The Singularity is Near. It's the movie accompaniment to my book, The Singularity is Near. It goes back and forth between a documentary and a narrative story of a young AI named Ramona, and gets more and more intelligent, more and more human-like. She finally decides to hire Alan Dershowitz, who's a famous civil liberties lawyer, who plays himself, to press for her legal rights to be recognized as a human. And the judge says, okay, I'll grant you human rights if you can pass a Turing test. So she gets coaching from Tony Robbins, who plays himself, to learn the secret of what
This
it
is
means
fiction?
to be human.
I said, this is fiction?
That was fiction, yeah. And it's somewhat tongue-in-cheek, but it is a serious issue. There are features of artificial intelligence that AIs can share their skills in ways that humans can't do. We can teach each other, but we can't just like transfer our thoughts and skills directly, like a digital file. So we don't think of AIs having human qualities, but once they really do have the depth of human intelligence, and the essence of a Turing test is to actually be convincingly emotional and empathetic. That's really the cutting edge of human intelligence. And once it does that, in my view, these are conscious beings. But I will say that consciousness is not a scientific issue. Some scientists talk about it like it's just an obvious thing that you can measure. There's no falsifiable experiment you can run that definitively says, okay, this one's conscious, this one isn't. There's no machine you can build, slide an end to the end, the green light goes on, okay, this one's conscious, this one isn't. That doesn't have some philosophical assumptions built into it. So one philosopher might require that it be squirting human biological neurotransmitters, otherwise it's not conscious. Dan Dennett, an AI philosopher at Tufts, would want it to make sure that it had a model of its own thinking. It didn't matter what the substrate is. That's maybe a little closer to my view. But these are all philosophical leaps of faith. There's really no scientific proof. So some scientists, including my mentor at times, Marvin Minsky, would say, well, you're right, it's not scientific, so therefore it's an illusion, we shouldn't waste time on it. That's not my view either, because our whole moral system is based on consciousness. A young child is precious because he or she is conscious. Non-conscious entities are only important insofar as they affect the conscious experience of conscious entities. So an important moral debate is who and what is conscious. That's behind the whole issue of animal rights. And we will debate the consciousness and therefore the moral rights and rights to liberties and so on of AIs. But it'll be tricky because of these other properties of AIs. But we will then ultimately enjoy those features as well.
Given the rate of progress, it's a philosophical issue, but it will be we'll be forced to confront it because of science.
Exactly.
Can you give us a date when we'll have to seriously consider?
Well, 2029.
2029, that's it?
And we'll merge with them in the early 2030s. A whole nother exponential trajectory is nanotechnology. There's a lot of progress being made, and there's already little devices actually you can put in your bloodstream that will carry out diagnostic and therapeutic procedures. I believe they'll be quite sophisticated in the early 2030s. As I mentioned, they'll extend our immune system. That's the third bridge to radical life extension. They will provide virtual or augmented reality, but most importantly, they will extend our intelligence and will merge with these intelligent entities. But it's really a continuation of what we've been doing for thousands of years with technology, is overcoming our own limitations, and no other species really does that.
Okay, I'm going to turn it to audience questions now because we've got some very good ones. What's the next major industry to die?
Well, I think every industry
As long as we're talking optimism.
every industry is transformed, so they don't die, they just get changed in nature. So if you viewed yourself in the horseshoe industry in around 1910, you probably didn't have a bright future, but if you saw yourself in the transportation industry, you did. So we're going to have transformations, let's say of agriculture, which is already greatly transformed. 38% of the population in the United States and Europe worked in agriculture in 1900. It's 2% today, but it's going to be further transformed, as I mentioned earlier, with vertical agriculture. Transportation is going to be greatly affected, not only by new means of autonomous vehicles, both on land and that fly, but really highly realistic virtual or augmented reality where you could be together. I'm giving a presentation actually in a few weeks to Australia where it'll be very realistic. I'll be able to walk along on stage and interact with other people on stage, and it will really look like I'm there. It's kind of clumsy in that it's a lot of equipment required, so it's something I can kind of carry in my suitcase. But we will actually be able to do that quite easily, and as we get to the mid to late 2020s, we'll be able to physically aggregate and do everything we do when we're actually physically together, including hugging each other, even if we're far apart. So this need to aggregate in cities and be very crowded and ignore 95% of the usable land, we will overcome.
Okay, so we've talked about cross-prohibitive arguments regarding tech, but let's say I have a $1 to $3 million by 2050. Am I going to be able to pay for immortality?
Well, I talk about 3 bridges to radical life extension in my health books and also science books. Health books co-authored with Terry Grossman, MD. Bridge 1 is what you can do right now. Bridge 2 is now unfolding, which is biotechnology, being able to reprogram the software of life. The enabling factor for that was the Genome Project. That was a perfect exponential. It doubled every year. The cost came down by half every year. That first genome cost $1 billion, finished in 2003. It's now down to $1,000. And our ability to understand, model, simulate, and most importantly, to reprogram this outdated software is also growing exponentially. And we're seeing now profound clinical applications. We can now fix a broken heart from a heart attack by reprogramming adult stem cells. I'm involved with a company where we're growing organs, run by Martine Rothblatt, who has spoken here at South by Southwest, kidneys, lungs, and hearts, installing them successfully in primates, which are pretty close to humans, coming to a human near you soon. This is all going to unfold in the next 4 or 5 years. 10 years from now, this will be a flood, and we'll really be able to program ourselves away from things like cancer. Immunotherapy is actually a very bright spot in cancer treatment. There's some spectacular trials where groups that are stage 4 terminal cancer have been brought to full remission. So all of this is unfolding and will be really mainstream over the next 10 years. The third bridge is medical nanorobots, with these basically, we have already devices in our bloodstream that keep us healthy. They are blood cells, our T cells, and other cells of the immune system. But they evolved tens of thousands of years ago, and it was not in the interest of the human species for us to live very long. So they didn't work against things that get us later on in life, like cancer. It says, oh, that's me, and doesn't go after it. So we can basically create non-biological T cells that are programmed to go against all pathogens, also overcome diseases of the organs, metabolic diseases. For example, the pancreas doesn't produce insulin, that's diabetes. So these devices will monitor the bloodstream for ideal levels of all these different nutrients, carbon dioxide, oxygen, toxins, puts them in, takes them out, augment the function of the organs. There's a scenario actually for every disease and aging process. So this is a 2030s scenario. So again, this will be expensive when it doesn't work. By the time it's perfected, it'll become like vaccines. Everyone will have access to it, ultimately very inexpensive. There's inherently a 50% deflation rate in information technology. That's what's keeping inflation in check, not policies by the government. It's really this increasingly pervasive influence of information technology. So ultimately, these things will be quite inexpensive.
All right, next audience question. What near-term, as in 1 to 3 years, innovation are you most excited about? And please be specific.
Well, yeah, 3 years actually brings us to the early 2020s. And I think then 3D printing will really get going, because we'll reach submicron resolutions, which is what you need for the interesting applications, like printing out clothing. So we'll increasingly be able to create the physical things we need. Vertical agriculture, I think it's more like 5 or 6 years for that to get going. Virtual realities had really a false start. I think that's actually typical. I've written about the life cycle of technologies. There's usually a lot of hype about a technology seen by visionaries, but the timing isn't there. Exponential growth doesn't mean instantaneous growth. So this audience probably doesn't remember the 1990s when if you had the website dog.com, you were a billionaire with the internet boom. And around the year 2000, the financial community said, now wait a second, you can't really make money with these internet companies. And we had the internet crash that almost brought down the world economy. But then it gradually came back as we actually got the price performance that we needed. So now you have little internet companies like Google, Apple, and Microsoft that are worth, I think, around $2 trillion together. The same thing will happen with things like virtual and augmented reality. It was a premature start last year. There's some really interesting devices, some of which are here, that look very promising. They need to be much more streamlined. You can't carry a big bulky device around. Ultimately, they'll be kind of in our eyeglasses and ultimately contact lenses, and we'll be used to being in augmented reality all the time. So you could be sitting around a table and a friend could be there, and it really will feel and seem like they're there, even though they're not. So virtual and augmented reality, I think, will take off in about 3 or 4 years.
All right, maybe a bit of an existential question for you, but in general, what are futurists going to do after the singularity?
There'll still be a future.
Like, you're going to take a day off?
We can actually start futurism for real, because we have to worry about all this legacy technology we have in the physical world. But the term singularity really is a metaphor on the event horizon that we see in a physics singularity. So we borrowed this metaphor from physics, and it's really not the infinite point in the center. Actually, physics does not allow an infinite point of mass and energy. It just gets beyond our ability to measure. And there's an event horizon around that so-called singularity that's very hard to see beyond because the information is kept in by gravity. That's a physics singularity. So in this historical singularity that we envision, it's again very hard to see beyond that horizon, because by 2045 I estimate we'll be enhancing our technology, our intelligence a billion-fold. That's such a profound transformation that we borrow this event horizon metaphor. But even in the physics singularity, we can use our intelligence to describe what it would be like to fall into a black hole, and we could describe what we'd see and what we'd feel if we could actually survive it. Similarly, in the historical singularity, we can describe what things would be like. We can use metaphors such as we'll create forms of music that we can't imagine today that'll be like what music is to humans compared to primates. And so we can talk about it in that way. But there'll still be a future. It'll just be changing much more rapidly, and it'll be much more profound, and I think we'll have a much greater need for futurists.
Okay, 2 more questions I want to get to here. First, the very important one, which is, what do you think of the theory that we may live in the Matrix?
Well, we have to define what a simulation means. So it's simply viewed that a simulation means that somebody created a computer program with a simulated world, like a computer game, and there are creatures that live inside that. And so we can imagine if a game like that became ultra sophisticated and somebody actually created a simulation of the whole universe that we seem to live in, that would be living in a simulation. So basically that some teenager for her science fair experiments has created the world that we live in. Then the concern is, how do you convince that teenager to keep the simulation going? And I think the answer is do interesting things. So be creative, create very entrancing music. The singularity is actually quite interesting. So if we can actually have a successful singularity, we'd keep the interest of that game maker in this other universe. But another view is it's not necessarily created by a conscious entity in another universe, but that the universe itself is a computer. There's certainly a lot of evidence for that. We live in a universe that encodes information. And it's actually quite a coincidence, because there are about 50 different constants in the standard model of physics, and they have to be within very precise levels for us to live in a universe that can actually encode information. But by the anthropic principle, we do live in such a universe. We wouldn't be talking about it if we didn't. So we live in a universe that is able to create subatomic particles that can relate to each other and encode information, and then create atomic structures that encoded information. And then there's been a series of indirections. Atoms aggregated into molecules. Molecules can encode information. There evolved a particular molecule, DNA, that could actually very systematically encode information and actually then create creatures that were described by that code. Those creatures then developed brains, and those brains then learned information. Those brains combined with an opposable appendage so that we could actually create technology, then created computers that could encode information. We then gave those computers intelligence based on trying to understand our own intelligence, and then enhanced our own intelligence by merging with those devices. All of those grand evolutionary steps resulted from the fact that we do live in a universe that encodes information. And a universe that encodes information is a computer. So you could say we do live in a simulation. But whether or not there's some grand creatures watching our simulation and doing that instead of watching weekly TV programs is a philosophical question at this point.
So I'm afraid we have to wrap it up, but I think
This is somebody who really is not just an author and an inventor, but somebody who thinks about the future in ways that I can't even possibly comprehend. So thank you for being with us. I want to start the conversation here, which is, you talk about the idea of physical immortality, and you say that this is going to be possible by 2045. Explain yourself.
Well, I'll never be able to come on the stage and say I've done it. I've lived forever, because it's never forever. But I talk about 3 bridges to radical life extension. I've written a few health books. Bridge 1 is what you can do right now to stay healthy the old-fashioned way, so that we can get to bridge 2. A key idea of mine is that information technology progresses exponentially, and health and medicine is now an information technology, and that was enabled by the Genome Project, which was a perfect exponential. And that first genome cost $1 billion. We're now down to a few $1,000s per genome. But it's not just collecting this object code of life that's progressing exponentially. Our ability to understand it, to model it, to simulate it, and most importantly, to reprogram it is growing exponentially. And we're now getting clinical applications of biotechnology. For example, you can now fix a broken heart, not yet from romance. That'll take a few more developments in virtual reality, but we can actually, half of all heart attack survivors have a damaged heart. We can now fix that by reprogramming adult stem cells. We're regrowing organs, successfully installing them with the patient's own DNA in animals, and we'll do that in humans soon. We could talk all day about these examples. What's now a trickle will be a flood by the end, within 10 years. That's bridge 2. And that'll get us to bridge 3, where we'll have medical nanorobots, little robots that are computerized, that are the size of blood cells, that basically finish the job of the immune system. We have intelligent devices the size of blood cells that keep us healthy. They are blood cells, or T cells, but they evolved thousands of years ago, and it was not in the interest of the human species for us to live very long. So they don't recognize cancer, for example, because that gets us later on in life. It thinks, oh, that's me, and doesn't go after it. We can finish the job with these medical nanorobots. There are detailed designs, actually, how to go after every disease once we have these devices. That's a 2030 scenario. So that's the third bridge. Ultimately, we're going to merge with artificial intelligence. We can talk more about that.
The singularity. The reason I wanted to bring this up is just the idea, as we all sit here trying to understand what the future actually looks like. And part of that future, in your mind at least, is something known as the singularity.
Right. Well, we start with the idea of extending our mental capacity with AI. So we've already done that. You misplaced your cell phone, so you're not enhanced at the moment. But you know, most people, if they leave their cell phone, they feel like they're incomplete. So they're not yet inside our bodies and brains. There are some people that have computers in their brains, like Parkinson's patients, but that'll be routine in the 2030s. Another application of these medical nanorobots will be to connect our neocortex, that's the outer layer of the brain, that's where we do our thinking, to the cloud. Now, if you remember, 2 million years ago, we got these large foreheads. We were, before that, walking around with a slanted brow and no frontal cortex. And we got this additional quantity of neocortex. And what we did with it is we put it at the top of the neocortical hierarchy. And as you go up the hierarchy, issues become more interesting and more complex. And that was the enabling factor for humanoids to invent language and art and poetry and newspapers and conferences. No other species does that. But it was a one-shot deal. Our skull couldn't keep expanding, or childbirth would have been impossible. We'll connect our neocortex wirelessly to the cloud, just the way your cell phone does it. Most of the things you do with that do not take place in the phone. They connect to the cloud. The cloud is pure information technology. It is doubling in power every year as we speak. And we will then connect to simulated neocortex in the cloud and add again, just like we did 2 million years ago, to our neocortical hierarchy. But this time it won't be a one-shot deal. The cloud is pure information technology. It's expanding exponentially. And so we will be a hybrid of biological thinking and non-biological thinking, which I believe has already started with these devices outside our body. And we'll become smarter. By 2045, we'll expand our intelligence a billion-fold. That's such a profound transformation that we borrow this metaphor from physics and call it a singular change in human history.
When do we get to designer babies? And I ask because I had spent some time in a research lab in Berkeley working with CRISPR, a gene editing tool, which is really on the cusp of where all this may ultimately go. Do you think that's realistic?
Yes, I mean, certainly there are genetic diseases we would want to edit out that are just devastating diseases, and that we are beginning to now and making exponential progress in understanding the genetic codes that cause those diseases. That, you know, if you were told you could edit that out of your child's genome, you would want to do that. I think that's much less significant than augmenting our intelligence through artificial intelligence. That's going to make us vastly more intelligent, far beyond what we could sort of engineer by optimizing our biology.
Right. Okay, final question for me, and then I want to throw it open to the audience. This is news you can use. Ray happens to take 90 different pills a day because he plans to stay alive for a very long time. Walk us through your regimen.
Okay, well, people say you take all these supplements and other pills, that's going to enable you to live hundreds of years, and the answer is no. That's just to get to Bridge 2, and Bridge 2 is not far away. According to my models, 10 to 15 years from now, we'll be adding more than a year every year to your remaining life expectancy. Now, life expectancy is a statistical phenomenon. You could have a computed life expectancy.
How old are you now?
People think I look pretty good for 95. I'm 68.
Okay, so tell us what you take.
Well, that would take us all day, but I'll give you one example of an actual prescription pill, metformin. It's a diabetes drug. We've known for years that all the people that take metformin, and there are millions because it's the most popular diabetes drug, have much lower cancer rates. So I did some research with some MIT scientists, and we discovered why. It actually kills cancer stem cells, which are the real cause of cancer. Now, people don't take it optimally, and you really need to take 500 milligrams every 4 hours to maintain a level that will really keep...
Is that what you do?
Yeah.
Okay.
But even people who take, you know, one every 24 hours have some protection, and we see dramatically lower cancer rates as a result. It's also a caloric restriction mimetic, meaning it causes some of the same changes that eating less causes without eating less. So I actually recommend anyone over 50 take that. So there's a long story.
We all want to call our doctor or go to Walgreens immediately. Tell us what else is on the list. Couple. And then I'll give it over, but this is selfish.
Phosphatidylcholine is you can buy it at Whole Foods. 90% of your cell membrane is that substance, that lipid. When you're 10, it's reduced by 90 or 95% by the time you're 90. That causes the organs to work less well. That's why your skin gets less supple. That's why the baby's skin is so soft and smooth. You can reverse that by simply supplementing with that substance. So there's a lot of different stories. I've written several health books about this.
Hi, Scott Lowen. The idea of radical life extension is exciting, but on a planet where the population is growing increasingly exponentially, talk a little bit about sort of resource utilization and sustainability, and how are we going to solve those issues?
Right. Well, as you know, the first thing that happens when nations get wealthier is the population growth rate goes negative. When we start to significantly reduce the death rate, the population will go up again. We have far more resources than we need. Take energy. So Tom Friedman, I don't know if he's here, but he's written a lot about energy. We have exponential growth, for example, in solar energy. Larry Page and I, this is before he became CEO of Google, were asked by the National Academy of Engineering to study emerging energy technologies. We selected solar because it had been growing exponentially for 25 years, doubling every 2 years. And at that point, it was 0.5% of the world's energy. And people say, 0.5%, it's a nice thing to do, but it's a fringe player, ignoring the exponential growth, because that's only 8 doublings from 100%. Now it's 2%, still growing, doubling every 2 years. I think Tom has a graph in his book that shows that progression. That's only 6 doublings from 100%. So I presented this to the Prime Minister of Israel recently, and he said, he was actually in my class in the Sloan School in the 1970s, and he said, Ray, do we have enough sunlight to do this with? And I said, yes, we have 10,000 times more than we need. Once we meet all of our energy needs from solar, we'll be using 1 part in 10,000 of the sunlight. And that's just an existence proof, because there's a similar story with geothermal, tidal energy, and wind, and so on. We have thousands of times more energy than we need. I mentioned vertical agriculture that will provide food at very low cost for the entire population. We'll be able to print out the other physical things we need ultimately with advanced AI-controlled manufacturing technologies in the 2020s. So we'll be able to meet the material needs of the population. I talked about snapping together homes from 3D printed Lego modules. People say, but land, I mean, we're all crowded together. Well, we're crowded together because we created cities as an early technology so that we could work and play together. Now that virtual reality, it's not yet competitive with real reality, but it's becoming more so. We are spreading out. My work group is all over the world, and we communicate just fine. That'll become more realistic as virtual reality and augmented reality become more realistic. Try taking a train trip anywhere in the world, and you see that 98% of the land is not being used. We use 40% of it for horizontal agriculture, which we'll replace with vertical agriculture. So we have plenty of resources for an expanding population. Even when we dramatically cut the death rate, the biological population will only double every 15 years or so. The power of these technologies doubles every 1 year. That's the exponential growth that I call the law of accelerating returns.
All right, so some of you are probably familiar with his work, some of you may not be, but let's begin, Ray, by talking about the law of accelerating returns, what that means for technology, lay out a framework for what's about to happen, and then we'll dig into how foreign policy is going to be turned on its head.
Sure. Well, that's the basis of my futurism. In 1981, I realized that the key to being successful as an inventor was timing. The inventors whose names you recognize, like Thomas Edison or my new boss, my first boss, Larry Page, we're in the right place with the right idea at the right time. And timing turns out to be important for everything from writing magazine articles to making investments to romance. You got to be in the right place at the right time. So I started with the common wisdom that you cannot predict the future, and I made a very surprising discovery. There's actually one thing about the future that's remarkably predictable, and that is that the price, performance, and capacity, not of everything, not of every technology, but of every information technology, follows a very predictable path. And that path is exponential, not linear. So that's the law of accelerating returns, but it bears a little explanation. So I had the price performance of computing, calculations per second per constant dollar, going back to the 1890 census through 1980, on a logarithmic scale where a straight line is exponential growth. It was a gradual second level of exponential, but it was a very smooth curve. And you could not see World War I or World War II or the Great Depression or the Cold War on that curve. So I projected it out to 2050. We're now 36 years later. It's exactly where it should be. So this is not just looking backward now and overfitting to past data, but this has been a forward-looking progression that started in 1981. And it's true of many different measures of information technology. And the progression is not linear, it's exponential. And our brains are linear. If you wonder why we have a brain, it's to predict the future. But the kind of challenges we had 50,000 years ago when our brains were evolving were linear ones. We'd look up and say, okay, that animal's going that way. I'm coming up the path this way. We're going to meet at that rock. That's not a good idea. I'm going to take a different path. That was good for survival. That became hardwired in our brains. We didn't expect that animal to speed up as it went along. We made a linear projection. The primary difference between myself and my critics, and many of them are coming around, is we're looking at the same world. They apply their linear intuition. For example, halfway through the Genome Project, 1% of the genome had been collected after 7 years. So mainstream critics said, I told you this wasn't going to work. Here are 7 years, 1%. It's going to take 700 years, just like we said. My reaction at the time was, well, we finished 1%, we're almost done, because 1% is only 7 doublings from 100%. It had been doubling every year. Indeed, that continued. The project was finished 7 years later. That's continued since the end of the Genome Project. That first genome cost $1 billion. We're now down to $1,000. And every other aspect of what we call biotechnology, understanding this data, modeling it, simulating it, and most importantly, reprogramming it, is progressing exponentially. And I'll mention just one implication of the law of accelerating returns, because it has many ripple effects, and it's really behind this remarkable digital revolution we see, is a 50% deflation rate in information technology. So I can get the same computation, communication, genetic sequencing, brain data as I could a year ago for half the price today. That's why you can buy an iPhone or an Android phone that's twice as good as the one 2 years ago for half the price. We put some of the improved price performance in price and some of it into performance. So you asked me actually just a few minutes ago, and a question that was also asked by Christine Lagarde, head of the IMF, at her annual meeting recently, how come we don't see this in productivity statistics? And that's because we factor it out. We put it in the numerator and the denominator. So when this girl in Africa buys a smartphone for $75, it counts as $75 of economic activity, despite the fact that it's literally $1 trillion of computation circa 1960, $1 billion circa 1980. It's got millions of dollars of free information apps, just one of which is an encyclopedia far better than the one I saved up for years as a teenager to buy. All that counts for 0 in economic activity because it's free. So we really don't count the value of these products. And people who compile these statistics say, well, we take into consideration quality improvement in products, but really using models that use the old linear assumption. So then Christine said, yes, it's true, the digital world's amazing, we can do all these remarkable things, but you can't wear information technology, you can't eat it, you can't wear it, you can't live in it. And my next point was all of that's going to change. We'll be able to print out clothing using 3D printers. Not today, we're kind of in the hype phase of 3D printing, but in the 2020s, early 2020s, we'll be able to print out clothing. There'll be lots of cool open source designs you can download for free. We'll still have a fashion industry, just like we still have a music and movie and book industry, coexistence of free open source products, which are a great leveler, and proprietary products. We'll be able to create food very inexpensively using 3D vertical agriculture, using hydroponic plants for fruits and vegetables, in vitro cloning of muscle tissue for meat. The first hamburger to be produced this way has already been consumed. It was expensive. It was a few $100,000, but it was very good.
You're on the Upper East Side. That's like what it costs.
But that's research costs. So it's a long discussion, but all of these different resources are going to become information technologies. A building was put together recently as a demo using little modules snapped together Lego style, printed on a 3D printer in Asia, put together a 3-story office building in a few days. That'll be the nature of construction. In the 2020s, 3D printers will print out the physical things we need. She said, okay, but we're getting very crowded. Land is not expanding. That's not an information technology. And I said, well, actually, there's lots of land. We just have decided to crowd ourselves together so we could work and play together. Cities was an early invention. We're already spreading out with even the crude virtual and augmented reality we have today. And try taking a train trip anywhere in the world, and you'll see that 97% of the land is unused.
All right, so lots coming. Let's talk about intelligence. So, like the phone in my pocket, it's better than I am at math, it's better than I am at Go, it's better than I am at a lot of things. When will it be better at me at holding a conversation? When will the phone interview you instead of me?
We do have technologies that can have conversations. I mean, my team at Google created smart replies, you know.
When Ray actually answers all of your emails, is another way to describe his job at Google, which is amazing.
Yeah, so we're writing millions of emails. And it has to understand the meaning of the email it's responding to, even though the proposed suggestions are brief. But your question really is a Turing equivalent question. It's equivalent to the Turing test. And I'm a believer that the Turing test is a valid test of the full range of human intelligence. You need the full flexibility of human intelligence to pass a valid Turing test. There's no sort of simple natural language processing tricks you can do to to do that. That's where a human judge can't tell the difference between talking over what he called teletype lines, basically instant messaging, with an AI versus a human. And if the human judge can't tell the difference, then we consider the AI to be at human levels, which is really what you're asking. That's been a key prediction of mine. I've been consistent at saying 2029.
Yep.
In 1989, in the Age of Intelligent Machines, I bounded that between early 2020s and late 2030s. And Age of Spiritual Machines in 99, I said 2029. The Stanford AI department found that daunting, so they held a conference, and the consensus of the AI experts at that time was hundreds of years. 25% thought it would never happen. My view and the consensus view, or the median view of AI experts, have been getting closer together, but not because I've been changing my view. In 2006, there was a Dartmouth conference called AI 50, celebrating the 50th anniversary of the 1956 Dartmouth conference, where AI, artificial intelligence, got its name by John McCarthy and Marvin Minsky, who was my mentor for over 50 years. And the consensus then was 50 years. So at that time, I was saying 23 years. Median, we just had actually an AI ethics conference at Asilomar, patterned on the successful biotech Asilomar conference of 40 years earlier. And the consensus view there was about 20 to 30 years. And I'm saying, well, at that time, 13. So the median view now is, I'm still more optimistic, but not by that much. And there's a growing group of people who think I'm too conservative. I think that a key issue I didn't mention with the law of accelerating returns is not only does the hardware progress exponentially, but so does the software. And that's a long discussion. But we can see now the daunting pace of progress with one milestone after another falling to AI. And we can talk about some of the techniques. But so I'm feeling more and more confident. And I think the AI community is gaining confidence that we're not far off from that milestone.
All right, so I got 12 more years I can do this kind of thing. So anybody in the CFR booking department, please keep inviting me because I do enjoy doing these and time is limited. Let's talk a little bit about regulation. There are a lot of people in this room.
Well, let me comment on that. This is not an alien invasion of intelligent machines from Mars. We create tools to extend our reach. We couldn't reach that fruit at that higher branch 1,000 years ago, so we invented a tool that extended our reach. Who here could build this building with our bare hands? But we created machines that extend and leverage our muscles. We can now access all of human knowledge with a few keystrokes. And we're going to literally merge with, with this technology, with AI, to make us smarter. It already does. I mean, these devices are brain extenders, and people really think of it that way.
Yeah.
And that's a new thing. I mean, people didn't think of their smartphones that way just a few years ago. They'll literally go inside our bodies and brains, but I think that's an arbitrary distinction. Even though they're outside our bodies and brains, they're already brain extenders, and they will make us smarter and funnier.
Well, I could use some of that. That'll probably be 5 years away. So let's talk about how to make this future go forward in the best way. So we have an opportunity here. You have 300 people who are going to be making some of the most important policy decisions. I see people from tech companies here making big decisions at tech companies, people in Congress, people in the White House, people probably in foreign ministries. Explain the sort of the framework for policymakers and how they should think about this accelerating technology, what they should do and what they should not do.
Well, I mean, there has been a lot of focus on AI ethics, how to keep the technology safe, and it's kind of a polarized discussion, like a lot of discussions nowadays. I've actually talked about both promise and peril for quite a long time. I started in the 1990s and did extensively in '99. You might remember Bill Joy's cover story in Wired.
I wasn't there at the time.
Right, but that was a reflection on my book, Age of Spiritual Machines, which had just come out, talking about the great promise and peril, and he focused on the peril, and it created quite a firestorm then. 2006, chapter 8 of The Singularity is Near is the deeply intertwined promise versus peril of GNR, genetics, nanotechnology, and robotics. Technology has always been a double-edged sword. Fire kept us warm, cooked our food, and burned down our houses. These technologies are much more powerful. It's also a long discussion, but I think we should go through 3 phases, at least I did, in contemplating this. First is delight at the opportunity to overcome age-old afflictions, poverty, disease, and so on. Then alarm that these technologies can be destructive and cause even existential risks. And finally, I think where we need to come out is a appreciation that we have a moral imperative to continue progress in these technologies, because despite the progress we've made, and that's a whole other issue. People think things are getting worse, but they're actually getting better, and we could talk about that. But there's still a lot of human suffering to be overcome. It's only continued progress, particularly in AI, that's going to enable us to continue overcoming poverty and disease and environmental degradation while we attend to the peril. And there's a good framework for doing that. 40 years ago, I alluded to this a moment ago, there were visionaries who saw both the promise and the peril of biotechnology, basically reprogramming biology away from disease and aging, neither of which was feasible 40 years ago. So they held a conference called the Asilomar Conference at the Conference Center in Asilomar and came up with ethical guidelines and strategies how to keep these technologies safe. So now it's 40 years later. We are getting clinical impact of biotechnology. It's a trickle today. It'll be a flood over the next decade. The number of people who've been harmed, either accidentally or intentionally, by abuse of biotechnology so far has been 0. That doesn't mean we can cross it off our list. Okay, we took care of that one. But it is, because we have to keep revising these guidelines because the technology keeps getting more sophisticated. But it's a good model for how to proceed. And we just had our first Asilomar conference on AI ethics. And a lot of these ethical guidelines, particularly in the case of, say, biotechnology, have been fashioned into law. So I think that's the goal. It's the first thing to understand. The extremes of, oh, let's ban the technology, let's slow it down. It's really not the right approach. Let's guide it in a constructive manner. There are strategies to do that. That's another complicated discussion.
Well, let's delve into that complicated discussion at least for a minute or two. You can imagine some rules that say Congress could say that anybody working on a certain kind of technology has to make their data open, right? For example, or has to be willing to share their data sets and at least to allow competitive markets over these incredibly powerful tools. You can imagine the government saying, actually, there'll be a big government-funded option that we're going to have, kind of like OpenAI, but run by the government. You can imagine a huge national infrastructure movement to build out this technology, so at least people with public interest at heart have control over some of it. What would you recommend?
Well, I think open source data and algorithms in general is a good idea. Google put all of its AI algorithms in the public domain with TensorFlow, which is open source. A lot of data is open source. I think that's a good direction to go in. I think it's really the combination of open source and the ongoing law of accelerating returns that will bring us closer and closer to the ideals. I remember in 4th grade, my social studies teacher put on the board, from each according to his ability, to each according to his need. And he asked the class, well, what's wrong with that? And we said, oh, that's great. And he said, well, that's the premise of communism. And everybody got, oh my God, is he a secret commie? And, but that is a good goal. Forced collectivism was a bad strategy. But I think we can get to that goal through a combination of open source and the ongoing exponential progress in both hardware and software. So I think it's a good direction to go in. There are lots of issues, such as privacy, that are critical to maintain. And I think people in this field are genuinely concerned about the issues. There was a lot of representation by Google and DeepMind at this Asilomar conference. It's not clear what the right answers are. I think we want to continue the progress. But when you have so much power, even with good intentions, there can be abuses.
What worries you? I mean, your view of the future is very optimistic. That's very encouraging to hear, but what worries you?
Well, I've been accused of being an optimist, but and you have to be an optimist to be an entrepreneur. Because if you knew all the problems that you were going to encounter, you'd probably never start any project. But I have, as I say, been concerned about and written about the downsides, which are existential. We had the first existential risk to humanity when I was in grade school. We would have these civil defense drills where we'd get under our desks and put our hands behind our heads to protect us from a thermonuclear war. And it worked.
It's true.
So we have new existential risks. These technologies are very powerful. And so I do worry about that, even though I'm an optimist. And I'm optimistic that we'll make it through. I'm not as optimistic that there won't be difficult episodes. World War II, 50 million people died, and that was certainly exacerbated by the power of technology at that time. I think it's important, though, for people to recognize we are making progress. There was a poll taken of 24,000 people in 26 countries recently and asked, has poverty worldwide gotten better or worse? 90% said incorrectly it's gotten worse.
Yeah.
Only 1% said correctly that it has fallen by 50% or more. There's a general pessimism that things are getting worse, the world's getting more violent. So I say, oh, this is the most peaceful time in human history. And people say, don't you pay attention to the news? There was just an incident a few days ago and a few days before that. And, well, our information about what's wrong with the world is getting exponentially better. And certainly it's far from a perfect world, but your chance of actually, Steven Pinker documents this in his book, The Better Angels of Our Nature. There's been an exponential decline in the likelihood of your being killed by interpersonal or state-sponsored violence. And so that's another long discussion.
Well,
but
since these people are not going to be killed, we're going to have a Q&A in about 5 minutes. So I'm going to ask you one more question, which is about their futures, which is, what should they do? Right? They're about to enter a world where the career choices are career choices mapped onto a world with completely different technology. So in your view, what advice do you give the people in this room?
Well, it really is an old piece of advice, which is to follow your passion, because there's really no area that's not going to be affected or that isn't a part of this story. My father knew he had a passion for music from a very young age. And music is relevant to this story. The neocortex is a hierarchy of modules, and we got an additional amount of neocortex 2 million years ago when we got these big foreheads. And what we did with it is put it at the top of the neocortical hierarchy, and that was the enabling factor for us to invent music. Every human culture we've ever discovered has music, and no other animals have music. Humor came with that additional neocortex. Language, art, science, technology, magazines. We're going to do it again. We're going to merge with simulated neocortex in the cloud. And so again, we'll be smarter. We'll create new forms of communication that are as profound as music is. Try explaining music to an animal that doesn't understand that concept. So everything is really relevant, and it's not going to, my view is not that AI is going to displace us. It's going to enhance us. It does already. I mean, who can do their work without these brain extenders we have today? And that's going to continue to be the case. And people say, well, only the wealthy are going to have these tools. And I say, yeah, like smartphones, of which there are 3 billion. I was saying 2 billion, but I read the new statistic now, it's 3 billion. It'll be 6 billion in a couple of years. That's because of this fantastic price performance explosion. So these technologies, only the wealthy will be able to have these technologies at a point in time where they don't work. By the time they work well, they're virtually free. So, find where you have a passion. Some people have complex passions that are not easily categorized, and so find a way of contributing to the world where you think you can make a difference. Use the tools that are available. The reason I came up with the law of accelerating returns literally was to time my own technology projects, so I could start them a few years before they were feasible. So try to anticipate where technology is going. And it's people forget where we've come from. I mean, just a few years ago, we had the little devices that looked like a smartphone, but they didn't work very well. And so that revolution in mobile apps, for example, hardly existed 5 years ago. The world will be comparably different in 5 years. So try to time your projects to kind of meet the train at the station.
All right. If Council Information Term members do not have questions for Ray Kurzweil, I'll eat my shoes, and already we have half the front 2 rows. So right here. Please state your affiliation, ask the question. A reminder, this meeting is on the record, so your words can and will be used against you.
So Adedayo Banwell, Deutsche Bank. With all due respect, sir, you're so smart, it's kind of scary. And I think the same holds true for the technology. So I was wondering, what sort of strategies do you envision for people in your spaces of explain this and to make it less scary for normal people?
Well, the unknown is scary. So part of my mission has been try to explain where we're going and show how it has been beneficial. We've overcome, I mean, human life used to be extremely difficult. If you want to read something scary, read about life 200 years ago. Thomas Hobbes described it as short, brutish, disaster-prone, disease and poverty-filled. And there's no understanding of the germ theory of disease. People got diseases all the time. There was no antibiotics. A routine infection would throw a family into economic desperation. There are no social safety nets. Life expectancy was 37 in 1800. And even the kings and queens didn't have amenities a century or two ago that the poor have today, like flush toilets and refrigerators and radio, TV, computers. So the future really will provide an opportunity to continue to overcome human affliction and add to our creativity. There's a lot of fear about jobs, but the movement has also been in the right direction. If I were prescient futures to 1900, I'd say, well, 38% of you work on farms and 25% of you work in factories. It's 2/3 of the population. But I predict in 100 years, that'll be 2% on farms and 9% on factories. And everybody go, oh my God, we're going to be out of work. And I said, well, don't worry. For every job we destroy at the bottom of the skill ladder, we're going to create more than one job at the top of the skill ladder. And people would go, oh, great, what new jobs? And I say, well, I don't know. They haven't been invented yet, which is part of the problem. We can clearly see today, we can see even better because we have better communication and knowledge, the jobs going away. If you're driving a truck or a car, you've probably heard about self-driving vehicles, and we can't see what's coming. If I were really prescient in 1900, I'd say, well, you'll be creating websites and doing data analytics and apps for mobile devices, and nobody would have any idea what I'm talking about. So some economists say, yes, that's all true, but it's slowed down in recent years. That's not true. The whole mobile app economy, which is many different ways to make money, didn't exist 5 years ago. And I think most importantly, not everybody's thrilled with their job, but an increasing fraction of people actually get some of their self-identification and gratification and self-actualization from their employment, which wasn't the case 100 years ago. So I try to articulate the benefits and what we can see that's positive about the future.
In the very front right here. I'd like to say, I am glad we don't all drop dead at 37. Thank you, Ray.
Hi.
Well, I gave a talk to junior high school kids, 13 and 14-year-old science winners from around the country, and I said to them, if it hadn't been for the scientific progress we've made, you all would be senior citizens, because life expectancy was 19 1,000 years ago.
Hi, Alana Ackerson, and I just did a doctorate looking at how the development of newer and better technology is a way that we as humans express faith in a better future for humanity. And so from that lens, I'd love to hear your thinking on, as we are now, as intelligence is now transcending us as humans in some ways, what are your thoughts about how we are going to be redefining our understanding of who we are as humans, and taking your phrase, an age of spiritual machines, how we are from a spiritual perspective? So how is this going to fundamentally change, our lens on these things?
Right, well, great question. We are the species that changes ourselves and changes who we are. That came with that additional neocortex 2 million years ago, and that we could then conceptualize different futures. We had one other evolutionary change, which is this modest appendage, opposable thumb. So I could imagine, oh, I could take that branch and I could strip off the leaves and create a tool. And then I had the dexterity to actually carry it out. And so we created a whole new evolutionary process of evolution, of technology. You mentioned spirituality. I think this is all a spiritual process. My theory is basically one of evolution. And so what do we see in evolution? Both biological evolution and technological evolution, which is really a continuation of biological evolution. I have a chart showing the acceleration of change, which goes very smoothly from biological to technological evolution. It took hundreds of millions of years for mammals to evolve, for example. And now we have paradigm shifts in just a few years' time. Well, what happens to entities in evolution? They get more complicated, they get more knowledgeable, they get more creative, they get more beautiful. So if we look at how God has been described in different religious traditions, I grew up in a Unitarian church where we studied all the world's religions, and there was a common theme. Although they all have different metaphors and different stories, God was described as an ideal, as being unlimited in what? In those very same qualities. All-knowing, infinitely intelligent, infinitely creative, infinitely loving, and so on. So we actually improve those very qualities at an exponential rate through an evolutionary process, never achieving an infinite level, but growing explosively in that direction. So we never become God, but we become more godlike in these various qualities. So you can say that evolution is a spiritual process bringing us closer to God. And the other implication that's spiritual, and really where that title, Age of Spiritual Machines, comes from, is what is spiritual? It's really a word for consciousness. Our whole moral system, our sense of values, is that consciousness is the precious thing. That's the sort of underlying debate in animal rights. Conscious entities are what's important. Non-conscious entities are only important insofar as they affect the conscious experience of conscious entities. So who and what are conscious is the key question, and that's the underlying question in animal rights. That'll be a question when it comes to AI. So I alluded to earlier, we're going to merge with this technology. I'd say we already have done that to some extent. Medical nanorobots will go inside our brain, connect our neocortex to the cloud. So your smartphone, even though it is itself a billion times more powerful per dollar than the computer I used when I was an undergraduate at MIT, it multiplies itself again a millionfold by connecting to millions of computers in the cloud. We can't do that directly from our neocortex. We do it indirectly through these devices. We'll do it directly in the 2030s, and not just to do things like search and translation directly from our brains, although we'll do that, but to actually connect to more neocortex. So it'll be just like what happened 2 million years ago when we got these big foreheads, and we got this additional neocortex, we put it at the top of the hierarchy. That was the enabling factor for humor and language and music and so on. We'll do it again, only unlike 2 million years ago, it won't be a one-shot deal. We couldn't keep growing this enclosure without making birth impossible. The cloud is pure information technology. It's not limited by a fixed enclosure. So we will become more and more non-biological. So people say, oh, we're going to lose our humanity. Well, if you define human as being necessarily purely biological, I think we're already not purely human anymore, because we're not purely biological anymore. And we're going to become increasingly non-biological, but that's who we are. I mean, that is the definition of human, the species that changes itself. It creates tools. It goes beyond our limitations.
Anybody conscious in the back of the room? How about way back there in red? Dark area. Maybe you're not in red, but.
Thank you. It's more of a pink.
My glasses aren't enhanced enough.
Remo with Senator Dick Durbin's office. Thank you. This is the most elegant description of the robots coming that I've ever heard. And I'm just curious, so much of the emphasis has been on sort of the really lovely side of human nature, on science and exploration. And I'm curious, as we sort of move more towards our robot partners, what about the dark side? What about war and war machines and violence? I think already in some early AI experiments, there have this issue of sort of when you take the internet in aggregate, there is sort of a hostility or negativity in verbiage that is put into some of these machines. And what is your thinking on that? Or what is the reaction, or what are the controls for that? And I ask that as someone I'm an optimist. I think, at least from sitting in Washington, one of the worries about this is, how do you filter for that when we haven't even been able to answer that question for the internet yet?
Yeah. Well, let me come back to what I think can be done about that, but just to make a overriding point, that the increase in communications, I think, has fostered democracy and peace. So that started with books in the Middle Ages, and then we had other forms of communication. You could count the number of democracies a century ago on the fingers of one hand. You could count the number of democracies 2 centuries ago on the fingers of one finger. The world is not a perfect democracy today, but that has been accepted as the ideal, and people at least argue that as to how they are a democracy. That's become the model. That wasn't the case a century ago. There wasn't that consensus. And the world has become more peaceful, as I just mentioned, and there's a lot of documentation on that. Doesn't appear to be the case because our information about what's wrong with the world is getting exponentially better. And there's actually an evolutionary preference for bad news, because it was actually in your interest, tens of thousands of years ago, for you to pay attention to bad news. A little rustling in the leaves, it might be a predator. That was important to pay attention to. The fact that your crops were 1% better than last year, that was not critical for your survival. It's for you to be aware of. That being said, we're learning a lot about how these platforms can be used to amplify all kinds of human inclinations and be manipulated. And a lot of this is fairly recent information that we're learning. But we can, so AI learns from examples. There's a motto in the field that life begins at 1 billion examples. And the best way to get examples is to learn from people. So AI very often learns from people. Not always. AlphaGo Zero just learned from itself by playing Go games against itself, but that's not always feasible, particularly when you're trying to deal with more complex real-world issues. There's a major effort in the field. It's going on in all the major companies and in open source research as well to de-bias AI, because it's going to pick up biases from people if it's learning from people, and people have biases. And so to overcome gender bias and other types of racial bias, that can actually be a goal. As humans, we pick up biases from all of the things we've seen. A lot of it's subconscious. We then learn as educated humans to recognize bias and try to overcome it, and we can have conflicts within our own mind. The metaphor that my mentor Marvin Minsky used in the title of his book, Society of Mind, I think is a good one, because I very often hear the society in my own mind bickering about some issue, and there's different factions for different issues. But there's a whole area of research to de-bias AI and to overcome the biases it may pick up from people. So that's one type of research that can overcome problems with machine intelligence. In these ways, machine intelligence, can be actually less biased than the humans that it learned from. Overall, though, I think despite the promise and peril that's intertwined in social media, it's overall been a very beneficial thing. I walk through airports and every child over the age of 2 is on their devices, and it's become a world community. And I think the generation now growing up, more so than any other generation, feels that they are citizens of the world because they're really in touch with all the cultures of the world.
Right here in the front, Adam.
Hey, Adam Getty with Ionic Security. Ray, really appreciate all the work you keep doing with Singularity. But I do want to leap forward to 2030 timeframe. We've got the nanobots, we're connected. Now I've got a collective set of kind of thought and almost infinite capacity comparative to where we are today.
They won't be until 2035. So.
All right, 2035, all right, 2035, we're there. That happens. And kind of on the same progression of more information has created more peace, better kind of understanding of a global community versus these isolated communities. When we have the ability to have that kind of much higher bandwidth access to this extraordinary processing and intelligence infrastructure, does that deeper appreciation now of everybody else and every other culture, because we have the bandwidth to absorb it and process it, what are the implications you see on nation state structures and global governing structures when the world is truly connected that way?
I mean, we're already part of the way there. There's some issue in the retirement funds in Italy, and the whole world not only aware of it, but it affects everyone. So we are not isolated islands and haven't been that way for a long time. And there's appreciation how issues of economics or foreign affairs anywhere in the world have an immediate effect on us. It's not just that we care about these other people. Old institutions continue. There's still horses and buggies not far from here. There's still mechanical typewriters. Religion is still an institution, but has much less effect than it did, say, a century ago. Wasn't that long ago in human history that it really governed and had deep influence on every facet of everyone's life. It now has a role that varies depending on the person, but it's a much less pervasive force. Same thing's true of nation states. I mean, people really are increasingly identifying as citizens of the world. And I think over time, nation states will become less influential. I mean, I think we're on that path.
Wait, can I just, in the last year in this country, we have not grown closer to the rest of the world, and a lot of people would say our democracy has not gotten better. Is this a blip in the ongoing continuing progress and mankind coming together, or is this, or are many people misinterpreting it?
Well, I mean, the polarization in politics in the United States and in some other places in the world is unfortunate. I don't think it is an issue for the kinds of things that we've been talking about today. We've had major blips in the world. World War II was a pretty big blip, and actually didn't affect these trends at all. I mean, one of the remarkable things I noted in '81 when I first noticed this is, where is World War II or World War I on these graphs? So it kind of has a mind of its own. And there may be things that we don't like in, say, certain government officials or the government. But there's very robust discussion. We're not in a totalitarian era where you can't voice your views. I'd be more concerned if we moved in that direction, but I don't see that happening. So not to diminish the importance of government and who's in power and so forth, but it's at a different level. The kinds of issues we're talking about are not really affected by these issues. Now, there are existential risks that I worry about that I mentioned, because technology is a double-edged sword.
On the far left.
Hi, Aubrey Ruby, Africa Expert Network. My question is about inequality. From a human history perspective, maybe we started out very equal as hunter and gatherer, but there were a lot of phases of most of human history where inequality was quite high. And I'm wondering whether you think the 20th century was an anomaly in that sense, and how the diffusion of technology is going to impact inequality if you look at Gini coefficients worldwide.
Well, I think there's been a worldwide movement towards greater equality. Ancient societies were not equal. First of all, gender roles were very rigid, and there was no concept of gender equality. My own family's been involved in this. My daughter's right here, but my great-grandmother started the first school in Europe that provided higher education for girls in 1868, taken over by her daughter, who became the first woman to get a PhD in chemistry, and wrote about this. The title of her book is One Life is Not Enough, which kind of presents my interest in life extension. But if you talk about gender equality, we've come a long way. But there's all kinds of issues. I mean, slavery was considered the norm, certainly here in the United States, but around the world not that long ago in human history. And there's been recent issues with gay rights and gay marriage, and there's a continual progression, I think, of human rights. This Unitarian church I grew up in, one motto was many paths to the truth, so we studied all the world's religious traditions, but they were also focused on the here and now and civil liberties, and we went to civil rights marches in the South in the 1950s. And so I think we are making progress. I mean, there wasn't even discussion of these issues not that long ago. I mean, when I was... Economic equality is getting better. Poverty in Asia has fallen by over 90%, according to the World Bank, in the last 20 years. They've gone from primitive agrarian economies to thriving information economies. Africa and South America have growth rates that are substantially higher than the developed world. So there's any snapshot you take, there's inequality, but it's dramatically moving in the right direction. Poverty worldwide has fallen 50% in the last 20 years. And there's many other measures of that. People say the digital divide, but the internet, smartphones are very strong in Africa. That's a change just in the last few years. So we're moving in the right direction. At any one point in time, there's grave inequality and people who are suffering, but the numbers are growing in the right direction.
Okay. Right, in the very far back, last man against the wall.
Hi, my name is Lester Malpine. I guess my question is a question very generic that you probably get asked every day, and I'm the father of 4 kids, so I think about it all the time. So, and that is really why we have people like yourself, but in our country, why do we score so poorly in STEM? Why do you think that happens, and what do you think is the answer to that? Because I'm trying to get my kids prepared for 2035.
Well, it's an interesting dichotomy. We do, on various measures, fall behind on STEM. There's still a gender issue with STEM. The girls are right up there with the boys up through junior high school, but then they tend to drop out, and we don't fully understand the reasons for that. There seem to be powerful cultural issues at work, and people are working on overcoming that, but we don't fully understand it. But despite all that, the United States leads in STEM. I mean, the leading high-tech companies are American. Certainly other countries like China are moving rapidly. But we do have kind of an entrepreneurial leadership. There's a frontier mentality that comes from the United States being a place that you went to overcome oppression and to seek a better life that is, I think, ingrained in the American character. And also, we are the land of of all the world's peoples. So we understand all the different markets around the world because all those people are here, and that's what makes up America. And that's not true of most other countries. There's some diversity in some countries, but nothing like the United States. I do think STEM literacy, scientific, technological, digital literacy should be an important part of education. It's shocking to me that many high schools don't teach computer software. They should be teaching programming in elementary school. It's a good way to think. It's a good way to develop intellectual skills and a good way to view the world. So I think this is a good thing for us to focus on. As a nation, we're doing well in STEM. I think just to be a world citizen, it's important to actually have literacy in these areas.
Right there in the middle.
Adam Perlman with the U.S. courts. Taking your hypothesis of a connected collective consciousness, maybe collective, maybe not, what does that do to individuality, comparative advantage on an individual level, and the concept of leadership if we're all connected through implants or anything else?
Well, yeah, another way of asking that is, aren't we going to all become the same if we all have access to all this knowledge and thinking capacity? I think we'll actually become more different. We're actually pretty much the same as, unenhanced. We all have a very similar architecture of 300 million neocortical modules, and it's a fixed capacity. We'll be able to delve much more deeply into specific issues or skills or areas of insight as we enhance our thinking capacity. And we can do that already to the extent that we have these brain extenders. It's very hard to write a book 30 years ago. My most important information technology was a roll of quarters to feed the copier in the public library. So we do have the ability to think more deeply. So people will, we already see a tremendous diversity, for example, of musical fields. When I was a kid, there was pop music and there was jazz and classical music, and that was it. And now there's hundreds of genres, and so that will continue. There'll be a tremendous diversity of ways you can approach subjects, and I think people will become more different when they have more capacity to think more deeply.
Right here in the front row, last question, because time always moves exponentially at the end of these, so you're out of it.
Jamie Ossoff from the Open Philanthropy Project. Thank you for coming to speak with us today. I hear from your remarks that you're making a prediction that artificial general intelligence is 12 years out. You mentioned a couple times that notwithstanding your optimism, you are concerned somewhat about existential risks. So I was wondering if you could elaborate a little bit more on what you mean by that, and what is the most important thing that you think technologists should be doing to reduce those risks?
Well, existential risks are risks that threaten the survival of our civilization. So the first existential risk that humanity ever faced was nuclear proliferation. We have had the ability to destroy all of humanity some number of times over. There's debate about what that number is, but it doesn't really matter. And these new technologies, it's not hard to come up with scenarios where they could be highly destructive or destroy all of humanity. So biotechnology, for example, we have the ability to reprogram biology away from disease. Immunotherapy, for example, which is a very exciting breakthrough in cancer. I think it's going to be quite revolutionary. It's just getting started. It's reprogramming the immune system to go after cancer, which it normally doesn't do. But biotarists could reprogram a virus to be more deadly and more communicable and more stealthy and create a super weapon. And that was the specter that spawned this first Asilomar conference 40 years ago. And there's been recurring conferences to make these ethical guidelines and safety protocols and strategies more sophisticated. And so far it's worked. But we keep making the technology more sophisticated. So we have to reinvent them over and over again. So we just had our first Asilomar conference on AI ethics. We came up with a set of ethics which we all signed off on. A lot of them are somewhat vague. I think if you look back at the Asilomar guidelines for biotech 40 years ago, it was the same thing. They got more teeth and more specificity and more significance over time. I think it's an important issue to give a high priority to. We're finding we have to build ethical values into software. a classical example is your self-driving car. The whole motive for self-driving cars is that, they'll eliminate 99% of the 2 million deaths a year from human drivers, but it will get into a situation where it has to make an ethical decision. Should it drive towards the baby carriage or towards the elderly couple or towards the wall and perhaps kill your passenger? Do you have an ethical guideline to your passenger who might own you? You can't send an email to the software designers in that circumstance. Gee, what should I do? It's got to be built into the software. So those are practical issues, and there's a whole area of AI ethics growing over this. But how do we deal with the more existential risks? Weaponization of AI, which is not something in the future. I mean, defense departments all around the world have been applying AI. There was a document going around asking people to agree to ban autonomous weapons, which sounds like a good idea. And the example that's used is, well, we banned chemical weapons, so why not autonomous AI weapons? It's a little more complicated because we can get by without anthrax and without smallpox. It's okay to just ban them. But autonomous weapon is a dual-use technology. The Amazon drone that's delivering your frozen waffles or medicine to a hospital in Africa could be delivering a weapon. It's the same technology. And kind of the horse is already out of the barn. So which is just to say that it's a more complicated issue, how to deal with that. But the goal is to reap the promise and control the peril. There's no simple sort of algorithms. There's no little subroutine we can put in our AIs. Okay, put this subroutine in and it'll keep your AIs benign. There are technical strategies when it comes to biotechnology and nanotechnology. But intelligence is inherently uncontrollable. If there's some entity that's more powerful than you and I and it's out for our destruction, the best strategy is not to get in that situation in the first place. And failing that, the best next strategy would be to get some other AI that's even more intelligent than the one that's out for you on your side. Intelligence is inherently uncontrollable. And so my strategy, which is not foolproof, is to practice the kind of ethics and morality and values we'd like to see in the world, in our own human society. Because this future society, as I say, it's not some invasion from Mars of intelligent machines. It is emerging from our civilization today. It's going to be an enhancement of who we are. And so if we're practicing the kind of values we cherish in our world today, that's the best strategy to have a world in the future that